In this video, I'll talk about how to change between sum and difference of sine and cosine and product of sine and cosine. Here we have two specific cases. The first one is from product to sum. It says sine alpha times cosine beta equals 1/2 sine alpha plus beta plus sine alpha minus beta. So this is from product to sum. The second one is from sum to product. Sine alpha plus sine beta equals 2 times sine alpha plus beta over 2 cosine alpha beta divided by 2. Now, these two formulas, they are actually equivalent. That means we can go from one to the other. Say we want to from the above one to the bottom one. Well, what you can do is we can simply say, we just set this as, if we set A alpha plus beta, this equals A, and we set alpha minus beta equals B, and then you quickly get the alpha equals A plus B divided by 2, and beta equals A minus B divided by 2. Now, if you replace alpha and beta by the two expressions, we immediately deduce this sum to product formula. Okay, now the proof of this product to sum formula is very simple. We just use the sum formula for sine. Let's do it. Let's prove of the product to sum formula. Okay, well, by the sum formula, or we say sum difference formula, we talked about in the previous video, and then we have sine alpha plus beta. This one equals sine alpha cosine beta, and then plus cosine alpha and sine beta. Okay. So this is the sum formula for sine. And then we look at the difference. Sine alpha minus beta, right? We simply change beta to negative beta. And this one equals sine alpha cosine beta, and then minus cosine alpha sine beta. If we take the addition, if we add them together, if I add sine alpha plus beta to sine alpha minus beta, and then I have two copies of sine alpha plus cosine beta. But here, for cosine alpha sine beta, what I get plus minus, so we just cancel with each other. Right? From here, then we immediately deduce the product to sum formula. Sine alpha plus cosine beta, two copies equals sine alpha plus beta plus sine alpha minus beta. Then you divide by 2. Similarly, we can deduce other product to sum or sum to product formulas. Or you just need to memorize these two things are equivalent, and then you can deduce others just from these two. For example, others. For example, I want to get sine alpha minus sine beta. Well, we know how you go from sine beta to negative sine beta. This one is just equals sine alpha plus sine negative beta, because sine is an odd function. And then we can just apply this, right? So we get this twice of sine alpha minus beta over 2. You replace, right? So this is just beta 2. We just change beta to negative beta, right? So beta to negative beta. And then we have the cosine. Cosine alpha plus beta divided by 2. Or another, let's say, we want to derive the product to sum, says cosine alpha cosine beta. Well, we know you can go from cosine to sine, you just pi over 2 minus the angle, right? So we say, okay, so what is this one? This is just equals sine pi over 2 minus alpha, right? And then we have this equals sine pi minus 2 times alpha times cosine beta. Now we just apply the formula. We apply this formula to here. we change alpha to pi minus 2 minus alpha. And what we have? We get A equals 1/2, right? So here's sine pi over 2 minus alpha plus beta. And then the other one is sine pi minus 2 minus alpha minus beta. Okay. Now, for here, this one equals pi over 2 minus alpha minus beta. And this one equals pi over 2 minus alpha plus beta. And then we just use the, again we use the identity, the trigonometric identity, which is sine pi over 2, as we already used here, minus theta equals cosine theta. So here we get is 1/2 cosine alpha minus beta, and then plus cosine alpha plus beta. So this is another from the product to the sum formula. Now, let's look at several applications of this product to sum and sum to product formulas. Example 1. This is a past AIME problem. The question says, we have angle alpha, which is pi over 2008, so it's in the unit of radian. We want to find the smallest integer n, part of integer n, such that this expression is an integer. Okay? Now, let's look at this s, which is the sum of bunch of cosine times sine. Just cosine alpha times sine alpha plus cosine 4 alpha times sine 2 alpha, and then cosine 9 alpha times sine 3 alpha. The pattern is, the general expression for each term is sine alpha times cosine n squared alpha. When we first look at this expression, it's like a mess, because you have a lot of combinations on sine and cosine addition plus products. When you see problems like this, a general strategy is try to use product to sum or sum to product formulas to write things out. Hopefully, we can have some cancellation, and then we can simplify the expression. Here, because each term is cosine times sine times cosine, then naturally we can try the product to sum formula. Specifically, what we have is, if I take this, then I say this is angle A, this is angle B. We can think of, also I have twice here, so I have twice sine A times cosine B, right? Because let's recall, this is one of those product to sum formulas. We have is sine A plus B and plus sine A minus B, right? This is, we have is product to sum. All right. Therefore, let's apply this to see what we can get, right? Okay, so let's apply this one to the general term solution. Okay, so we have each term, so that's the 2 cosine m squared alpha times sine m alpha. As we put there, we have this one to be A, this to be B, and we apply the formula. So this equals sine, here is the m alpha plus m squared alpha, and then plus sine n alpha minus n squared alpha, right? Let's look at what is inside the sine function. Here's n alpha, m squared alpha, I can rewrite as n times n plus 1 times alpha. And here is minus n squared and n, so this equals, so this equals is negative n minus 1 times n alpha. And let's recall, we know sine function. Sine function is odd function, so I can put negative in front of it, and this will give me. So we have here. So this equals sine n times n plus 1 alpha, and we have the minus. So here's minus. We have minus sign. So this minus sine times n minus 1 times n alpha. Now here's the point. You see, those terms, they are basically the same. They have the same expression, but just apply into different n. And the important thing is here's plus minus. What do we get is basically alternating sum, plus, minus, plus, minus, plus, minus, and then we'll get cancellation, since this one will just be cancelled with the previous term. Okay, let's write out. From here, we derive our s. We can write our s equals. Okay. So as we look at the s expression, this one is just n equals 1. This is n equals 2. This n equals 3. We just apply the formula. So my s is sine. The first term is what? It's sine n equals 1. So that's sine 2 alpha. N equals 1. So that's 0. It's just okay. It's just sine 0. And this is first term. It's the first one here. And then we plus the second term, which is angle 2. So that's sine 6 alpha minus sine 2 alpha, so that's n equals 2. And then we plus its sine, this is 3, so we output 3, so it's 12 alpha and minus sine 6 alpha and go to the last one, right? So we have the last one is this expression, so this is sine, that's n times n plus 1 alpha and minus sine n minus 1 times n alpha. We just sum them up, right? All the way. Okay, now clearly, when you look at this, we get the cancellation we hope for, right? Okay, so we have this one is just 0, it goes away. And then sine 2 alpha cancel with sine 2 alpha. And we have sine 6 alpha cancel with sine 6 alpha. And we expect like cosine alpha, the 12 alpha of course will cancel the 12 alpha that is behind it. Also we have the last one will also be, this one will also cancel with the one before it. So eventually what is left? What is the final term that survives is sine n times n plus 1 alpha. Okay, so as a conclusion we get s equals sine, this is n times n plus 1 and alpha. Now, I can plot alpha into this expression. Okay, you see, so here what we have is the sine. I put, so it's n times n plus 1 times pi divided by 2008. Now, what is the goal? The goal is we want this one to be an integer. This is what we want. So we want this to be an integer. For a sine function, in order for a sine function to be integer, what do we have? Right, so a sine function changing from 1 to negative 1. So integer value could be 0, 1 or negative 1, right? So we want this is either 0, 1 or negative 1 because we want to be integer. Now, for a sine function, in order for this one to be 1, 0, negative 1, here it's positive, then what is inside shall be integer multiple of pi over 2, right? From here we deduce what we want is n times n plus 1 times pi over 2008. We want this one equals integer multiple of power 2. So we want this to be k times pi over 2, and k of course is positive integer. Alright, let's first simplify this. We have a pi, they cancel with each other. From here I deduce, right? So we deduce from here. What we get is n times n plus 1 equals 2008 to there. So it's k times 1004. Okay, so then what we want is 1004 is n times n plus 1 is divisible by 1004. So 1004. So this just implies n times n plus 1 is divisible by 1004. Alright, now let's factorize. Let's factorize 104. This one equals 4 times, this is 2, 5, 51, and 251, it's a prime number. This one is a prime number. It's a prime number. Okay. Alright. So we want n times n plus 1 is divisible by 1004. It's equal to say this one is divisible by 4 and 251. But 251 is a prime number. This 2 is divisible by 251 means one of them is divisible by 251, right? Okay, so from here we derive either n is divisible by 251 or n plus 1 is divisible by 251. This notation just means n plus 1 is divisible by 251 and n is divisible by 251. Now we have because here we're looking for the smallest, right? We're looking for the smallest. And then we have two choices. Either it's okay, I just put n to be 251, or I put n plus 1 to be 251. But if n is, okay, so for this is what we have. Okay, so let's look at the first option. N is 251. Now if n is 251, n plus 1 is 252. 252 is divisible by 4, and which is okay because we could also take care of the 4. So this one is fine. Alright, and then you say, okay, maybe I can make it smaller. I put n plus 1 to be 251, but if n plus 1 is 251, then n, the next one, the second choice, we say, okay, let's look at n equals 250. But n 250 is not divisible by 4, but this guy is not divisible by 4. Therefore, this is not valid. Since we need to make sure n times n plus 1 is divisible by both 4 and 251. Alright, so if you combine them together, the final answer, the smallest one, is n equals 251. Example 2. This is a key step in a previous AIME problem. The question says, in triangle ABC, if we know the cosine 3 times angle A plus cosine 3 times angle B plus cosine 3 times angle C equals 1, then we can conclude one of them, ABC, has to be 2 power 3, or equivalently 120 degrees. Okay. For this problem, essentially, what we need to do is solve this trigonometric equation. First, let's simplify a little bit solution. Because we know, so try to link the A, B, C together. You see here we have 3 unknowns, right? So A, B, C. Let's use trigonometric identities to reduce the number of variables. Well, because we know that A plus B plus C equals pi, and then this implies 3C equals 3A, so it's 3 pi minus 3A plus 3B, okay? And then we can use the trigonometric identity associated with cosine function. This tells us cosine 3C equals negative cosine 3A plus 3B, right? So we have this one, cosine 3A, this equals negative cosine 3A plus 3B. Therefore, I can move this term to the right hand side, and this will reduce this trigonometric equation to just one. There are just 2 unknowns, A and B. So from here, we deduce equation 3 cosine 3A plus cosine 3B equals 1 plus cosine 3A plus 3B. Okay, what's next? Because here are cosine plus cosine and 1 plus cosine, and then we can try to use the sum. So this is sum to product formulas, and hopefully we are able to get some kind of factorization. Alright, so that is also a quite a common technique to solve, to handle trigonometric equations. Okay, so let's do it. Because here's cosine and cosine. The trigonometric identity we use is cosine plus cosine. So here's what we are going to use. We have the cosine alpha plus cosine beta equals. So cosine alpha plus cosine beta equals twice cosine alpha plus beta divided by 2 and times cosine alpha minus beta divided by 2. So that's how we handle from sum to product. And then also we have 1 plus cosine. And for this one we can use the double angle formula. So if we recall, so 1 plus cosine 2 alpha equals twice cosine alpha squared. Or equivalently, we have 1 plus cosine alpha. This equals twice cosine square alpha divided by 2. Wow, these two things obviously the same, and sometimes you call this a double angle, this is a half angle. Okay. Anyway, so what we have is then I can apply this formula to right here, and I can apply this to here. We can rewrite the equation as, from here we deduce the twice of cosine 3a plus 3b over 2 and cosine 3a minus 3b over 2. This equals, okay, so here is twice, so this is equal to that. This is twice cosine squared 3a plus 3b over 2. Okay, so here we basically treat 3a, right? So this as the alpha and this as the beta, right? Okay, and when we just do from sum to product formula. Now here's the point. When you look at this new equality, we notice there's a common factor. That's a cosine 3a plus b divided by 2 and cosine 3a plus b divided by 2. The point is, then we can separate into two simplified equations. One is this one equals 0. Or if this one is not 0, then we can just cancel it, right? Alright, so we divide into, so we can look at two cases. Case 1. If I have the cosine 3a plus 3b over 2 equals 0. Now, well, usually we know if I have the cosine value of angle is 0, that means the angle is r multiple of power 2. Let's look at the range of 3a plus 2b over 2. The range of this is between 0 and 3 pi over 2. Okay, so in particular, it's less than 3 pi over 2 and it gets 0. Accordingly, in order for this one to be 0, there's only one choice. This one has to be pi over 2, right? So from here we divide. We get 3a plus 3b over 2. This is pi over 2. And from here, we just deduce a plus b is pi over 3. And this tells us the c is pi, 2 pi. So c equals 2 pi over 3, which is 120 degrees. The point is, for this case, we get the angle c is 2 pi over 3. Now, let's look at case 2. So case 2 is, this is not 0. So case 2, we have the cosine 3a plus 3b over 2. This is not equal to 0. And then we can just cancel this cosine 3a to b on both sides. And this leads to, again, it's a simplified equation. So from here we just get the cosine 3a minus 3b over 2 equals cosine 3a plus 3b over 2. So that's what we have. Alright, now if I look at the range of these two angles, 3a minus 3b over 2 and 3a plus 3b over 2, these two angles, it's less than 3 pi over 2, but bigger than negative 3 pi over 2 for both of them. if I have two angles, say cosine one angle equals cosine another angle, then the relation between these two angles, either the difference is say alpha, say cosine alpha equals cosine beta, then I must have the alpha either equals beta plus integer multiples of 2 pi, or alpha equals 2 pi minus beta plus integer multiples of 2 pi, right? Now consider these two things that are within the range, 3 power 2 and negative 3 power 2. This tells us we only have two scenarios. One is this one equals 2 pi plus that when this is negative, or this one equals 2 pi minus this when this one is positive. Okay, alright, so this leads to two situations. Case 1, well here we get the subcase as a case 1. I have 3a plus 3b over 2 equals 2 pi plus 3a minus 3b over 2. That's when this one is negative. From this case, we immediately derive the b equals 2 pi over 3, or we say 120 degrees. So for this case, b is 2 pi over 3. Or we say the second case. The second case is 3a plus 3b over 2 equals 2 pi minus 3a minus 3b over 2. This is minus, it's minus. So that's the case when this angle is positive, right? So for this one we derive a equals 2 pi over 3, or equivalently 120 degrees. Okay, so far we have exhausted three scenarios. We call the case 1 is when this one equals 0, and that gives us angle C is 120 degrees. And then we got case 2, when this one is not 0, we have two subcases. One gives us B is 120 degrees. The last one gives us A is 120 degrees. Okay. If we look at the solution of this problem, we see the key is we use this product. So this is the sum to product formula to factorize this trigonometric equation. The point is that we have a common factor that comes out, which allows us to simplify the equation.